This is Calculus 2. What are you going to do this session? We're going to do area between the two curves. What do you have to do? Find the area between the two curves. First, set up the integrals to find the area bounded by two curves. Second is identify which function is top or bottom or right and left in the given interval. Third one is split interval when curves intersect. Finally, we have a calculate exact area using definite integral. I'm gonna start with vertical slices. So this one is area between the two curves. Top curve is y equal f of x. Bottom curve is g of x. So we're gonna find the area between the two curves as a and b, x equal a, x equal b. Now, I'm gonna put the vertical slices, vertical rectangle right there. Put the xi, any point in that rectangle, xi, we want to find the area of that rectangle. So area of a rectangle is base times height, right? So I'm going to put the area of that small rectangle is ai equal, what is the base? Base is very small interval. Length of interval gonna be delta x. I'm gonna put the area, the length of base. We have to find the height. First one is f of x. That's gonna be first height, but x point is xi in the rectangle, so that's gonna be fxi. The other one is g of x. That's gonna be gxi. Put together, guys, fx minus g of x. So that's gonna be height of this rectangle. So how can find the area of a rectangle? Height gonna be fxi minus gxi times base. That's how to find area of vertical slices. We find we find the area of vertical one slices. How gonna find all of area of S? So let's see. We're gonna put the lot of rectangle in the area. Previous slides, we showed to find the area of one rectangle. Now, we want to find area between the curves. So I'm gonna put the rectangle in the S. So that's the lot rectangle right there. So I'm gonna find area of S. That's gonna be sum of all the area of a rectangle and take n. How many rectangle? N go to the infinity. That's how to find the area of S between the two curves. So how can change this into the definite integral? That's gonna be a and b f of x minus g of x dx. So now we have to understand this area formula between the two curves. So first you have understand interval of x, we're gonna integrate over. That's gonna be a and b. Then we see top curve gonna be f of x, bottom curve gonna be g of x. And slice, you're gonna slice vertically, so that's why dx. Another way put this integral formula for area gonna be area A gonna be interval a and b, top function is f of x minus bottom function of g of x dx. To find area bounded by curve y equal e to the x, y equal x, line x equals 0, y-axis, and x equal 1. That's you have blue region. That's the area we want to looking for. So Can you see the vertical slices right there, right? Vertical slices base gonna be delta x, that's gonna be dx. So we have area gonna be a and b, interval of x, top function and bottom function. So that's we're gonna find the area between the two curve in this problem. So what is the interval of x? 0 and 1, guys. What is top function? E to the x, the bottom function is y equal x. So you have this one. So 0 and 1, interval of x, we're going to integrate. Top function is e to the x, bottom function going to be x dx. Now we have to do definite integral by using first fundamental theorem. So we have to find antiderivative e to the x, antiderivative x squared over 2. Where to where? From x equals 0, x equal 1. So first you plug in x equal 1, you have e to the 1 minus 1 and a half, minus you plug in x equals 0, e to the 0 minus 0 of 2. E to the 0 is 1, 0 of 2 is 0. You have e minus 1 and a half minus 1, simplify negative 1 and a half minus 1. That's gonna be 3 over 2. So that's how to find the area between the curve. Another example right there. See, we have find area in the red region right there, guys. So as you see it, so this one is top function gonna be y equal x squared plus 2. Bottom function gonna be y equal negative x. Line gonna be x equal 0, x equal 1. Can you set up the integral for area? Guys, look at this. That's a slice vertically. So you have to vertical slices. So we have area gonna be right there. A and B, interval of x, top function and bottom function. Interval gonna be 0 and 1. That's interval of x. Top function is x squared plus 2. Bottom function gonna be negative x. So we set up the integral 0 and 1. Top function gonna be x squared plus 2. Bottom function gonna be negative x. Simplified integrand gonna be 0 and 1, x squared plus 2. Negative, negative, positive, x. I switched x and 2 right there, guys. You can find antiderivative x squared plus x plus 2, right? So first one is x cubed over 3 plus x squared over 2 plus 2x. Low limit x equals 0, upper limit x equal 1. Now we have plug in x equal 1 first. That's gonna be 1 over 3 plus 1 over 2 plus 2. When you plug in x equals 0, that's gonna be 0 right there, guys. So you can simplify first part. That's gonna be 17 over 6, guys. That's you find the area between the two curves when you slice vertically. Now, we have a little challenging question to find the area between the two curves. So look at the graph right there, guys. We want to find the area, just total area, S1, S2, S3. That area, region bounded by f of x, g of x, and a and b. Some part of area, top function is f of x, bottom function is g of x. Another part is g of x, f of x. That case, you have to find intersection first. So first intersection between the two curves is C1. Second intersection between the two curves is C2. That case, how gonna find area between the two curves? A gonna be S1 plus S2 plus S3. Why? Because top function and bottom function are different in each region. That's why you separate the interval, find each area separately. So first you're thinking about S1 right there, guys. What is S1 is A to the C1. That's the interval of X. Top function gonna be f of x, bottom function gonna be g of x dx. That's the first area S1. area of S2 gonna be interval of x, C1 to C2. What is top function? G of x, bottom function gonna be f of x. So that's how to find the S2, area of S2. S3 gonna be, see that interval? C to the B, top function gonna be f of x, bottom function gonna be g of x dx. Guys, keep in mind the area can be negative, so you have to make sure that split the interval. What is the top function? What is bottom function over each interval? So what is area A? You have S1, A and C1 fx minus g of x dx. 2, interval C1 to C2, g of x minus f of x dx plus S3 gonna be C2 to the B fx minus g of x dx. So when you find area A bounded by fx g of x, but they have intersection. You're gonna find the intersection first and split the interval looking for the top function and bottom function. You set up the integral right for the area. This case. I have curve y equals sine x, y equals cosine x. Line gonna be x equals 0, x equals pi over 2. Can you see intersection over the 0 and pi over 2? You see intersection gonna be x equals pi over 4. Two area. First one is A1, second is A2. So we have to find area A gonna be A1 plus A2 right there. So what is A1? First to find A1, that's gonna be 0 and pi over 4. That's the interval. Then top function gonna be cosine x, bottom function gonna be sine x dx. Because that's still vertical slices. A2 gonna be, guys, A2 gonna be right there. What is interval? Pi over 4 to the pi over 2. Top function gonna be sine x, bottom function gonna be cosine x dx. So what is the area of A? That's gonna be A1 first. A1 gonna be 0 and pi over 4 cosine x minus sine x dx. A2 gonna be pi over 4 pi over 2 sine x minus cosine x dx. Let's find the antiderivative. Cosine, that's gonna be sine. Antiderivative sine gonna be negative cosine x. So we find the antiderivative of each integrand. That's gonna be sine x plus cosine x. 0 and pi over 4, that's the first integral. Second integral will be negative cosine x minus sine x pi over 4, pi over 2. Let's do the first one. X equal pi over 4 sine pi over 4 cosine pi over 4. That's going to be same square root 2 over 2. So you have square root 2 over 2 plus square root 2 over 2. So when you plug in the 0, sine 0 and cosine 0, you're going to have it. Sine 0 is 0, cosine 0 is 1. That's going to be 0 plus 1. Now you plug in the pi over 2. Sine pi over 2 is 1, cosine pi over 2 is 0. That you have 0 minus 1. You plug in pi over 4. We already did it. That you have negative square root 2 over 2, negative square root 2 over 2. You're going to simplify this. It's parentheses. The first one is square root 2 minus 2 plus square root 2. Square root 2 plus square root 2 is 2 square root 2 minus 2. Guys, remember that when you have intersection over the interval, you have to find the intersection and split the interval. Find each area. What is the top function? What is bottom function? Let's do another case to find the area bounded by function. But that case, we're gonna use horizontal slice. Horizontal slice. Guys, look at this. I slice horizontally. That case, dy. This one is a height. Base gonna be, guys, fyi minus gyi. Height gonna be delta y. So how gonna change this into the integral notation? Gonna be integral d and d. This case, integral of y, fy minus gy dy. Another way, write this formula gonna be a gonna be D and D, right function and left function dy. Here is very careful when you slice horizontally, you're gonna find the interval of y. Function is right function and left function. That gonna be function of y, not the function of x, guys. Very careful with that. Let's have example. So first example, right? Horizontal slices. Look at this graph, guys. We have shade area, the colored area by blue. So we have horizontal slices. Horizontal slice meaning is we have to find interval of y. Okay, so here is right there. Horizontal slice meaning is we have to find interval of y, c and d, right function and left hand function. That's function of y that you have to do it. Right function is a line, so we have to find the right function first. We have left function that we have to find curve. So first one is right function. You see that that's the y plus 1. How can get the y plus 1? You solve for x. That's we have to do that. X equal y equal x minus 1. Solve for x. You move the 1 the other side. You have x equal y plus 1. That you find the y plus 1. What is left to function right there, guys? So we're gonna using curve parabola at y square equal 2x plus 6. We solve for x. That's we have to do it right there. Y square equal 2x plus 6. You solve for x. 2x equal y square minus 6 divided by 2. X equal y square over 2 minus 3. So let's just set it up. So we find interval of y, not x, because this one is horizontal slices. So we have find interval of y negative 2, 4. So area gonna be negative 2 and 4. Right function gonna be y plus 1. Left function is y square over 2 minus 3. Horizontal slice gonna be dy. So we find definite integral by integrand. So what is gonna be y minus y square over 2, 1 minus 3 gonna be 4. So that's we have y minus y square over 2 plus 4 dy. So let's find the antiderivative. Y gonna be y square over 2. Y square gonna be y cube over 3. 2 times 3 is 6. That's why negative y cube over 6 plus 4y. X equal negative 2 and 4. So let's find the area. So we have this one right there. So first you plug in x equal 4. That's gonna be 4 square over 2 minus 4 cube over 6 plus 4 times 4 minus you plug in the x equal negative 2, negative 2 square over 2 minus negative 2 cube over 6 plus 4 times negative 2. So first parenthesis you simplify 4 square over 2, 16 over 2. 4 cube gonna be 64 over 6. 4 times 4 is 16. 16 divided by 2 is 8. 64 over 6 simplifies 32 over 3 plus 6. Second parenthesis is gonna be negative 2 square is 4, 4 over 2. Negative 3 cube gonna be negative 8 over 6. 4 times negative 2 is negative 8. So you're gonna put this one gonna be 4 divided by 2 is 2. Negative, negative, positive, simplify 4 and 3 minus 8. So now 8 and 16 gonna be 24 minus 32 over 3. 2 and negative 4 gonna be negative 6, negative, negative, positive. Negative positive gonna be negative 4 and 3. 24 plus 6 gonna be 30 minus 32 4, 36 over 3. You can simplify 36 over 3 is 12. 30 minus 12, that's gonna be 18. That's you find area between the curve by using horizontal slices. Let's have one more example right there, guys. So look at this one. Find the area bounded by curve fx is x squared, g of x 2 minus x. We want to use horizontal slices. Horizontal slice. What do you need, guys? You need interval of y, guys, interval of y and right function and left function. That's you need it, guys. Make sure right function and left function. dy. You're gonna integrate with respect to y, so we have to find function of y. So first, right function, can you see the right function is gonna be line? G of x 2 minus x, we have solved for x. So y equal 2 minus x, solve for x. So x equal 2 minus 1. Left function gonna be, that's gonna be y equal x squared. So we have find x, solve for x. X gonna be square root y. Only positive part you're gonna take it. So let's find the interval of y, 0 and 1. That's the intersection right there, guys. So area between the two curves, 0 and 1. Right function gonna be 2 minus y. Left function gonna be square root y and dy because that's the horizontal slices. So you can find antiderivative, right? 2 minus y square root y. I just have the antiderivative square root y. That's going to be 2 over 3, y 3 over 2. So we find the antiderivative 2y, antiderivative y square over 2 minus 2 over 3, y 3 over 2. So you plug in the 1. 2 minus 1 and a half minus 2 over 3, plug in the 0, definitely 0. You're going to simplify 12 over 6 minus 7 over 6. Area going to be 5 over 6. So let's have one other example. We're thinking about which method much easier, horizontal slice, vertical slice. It depends on the area, depends on the region. So you have to make a decision which method you're going to use it. So I have the problem here, guys. I consider two slices. One is vertical, that we're gonna do it. Second part is horizontal. So let's just start the vertical first, guys. When you wanna do vertical slices, first you see the intersection between the two curves. That's the x equal 1. So 0 and 1, guys, that's vertical slice. That's gonna be red part. 1 and 3, that's the green slices. Two area A1, A2 should be separate because interval of 0 and 1, top curve is square root x. Interval of 1 and 2, top curve gonna be g of x. That's different, guys. So we have separate to find the area of region. So how gonna set up? A gonna be A1, 0 and 1, guys, square root x because that's the top curve. Bottom curve is x equals 0, so I didn't put it. Second is A2 gonna be, guys, 1 and 2, 1 and 3, guys, 1 and 3. 3, top curve gonna be 3 over 2 minus x over 2 minus 0. That's you're gonna find the area of A. But same region, we're gonna use horizontal slices. Horizontal slices right there, guys. So horizontal slices, we have to find the interval of y. When you see the horizontal, we have right function, left function. Right function gonna be y equals 3 over 2 minus x over 2. So we have to solve for x, guys. So x over 2 equals 3 over 2 minus y. You times 2x equals 3 minus 2y. We do the same thing in the left function. That's going to be y equals square root of x. But we have find function of y. That's going to be solved for x. So you square both sides, x equal y squared. So now area gonna be, find the interval of y, 0 and 1, guys. The interval gonna be 0 and 1. Right function gonna be 3 minus 2y. Left function gonna be y squared dy. So you have to make a decision on which slice you're gonna use, vertical, horizontal. So depends on the question, you have to make a right decision to find the area between the curves. So here is takeaway, key takeaways for area between the curves. Area between the curves is bounded by integrating the difference. One is gonna be top function minus bottom function. That's gonna be dx. That's the vertical slices. Another way you find the area, right function minus left function, that's the horizontal slice gonna be dy. So make sure, guys, you're gonna using which one? Top and bottom, right and left before setting up the integral. Another important thing is curve is intersects with the interval. You have to split the integral and the intersection points, and then you're going to use definite integral to calculate exact area.